Hello, my math friends. This is Mrs. Schlecht, and in this video, we are going to start looking at ratios. All right, so before we get going, there's a few materials that you need in order to be successful for this activity. First, you're going to need your Envision book. Hey, guess what? We're in volume 2 now, volume 2. Second, you're going to need your math notebook to take some wonderful notes. Third, don't forget your pencil. And fourth, last but certainly never ever least, that positive math attitude. All right, my friends, so this video goes really well with lesson 5-1 in Envision, volume 2, my friends. The key concepts page can be found on 270. Now, ratios, super exciting stuff, super excited to get into it. So first, before we get into like super cool math, let's just talk about what these ratios even are. I would make sure to have my math notebook out with me at this point in my life. All right, my friends, so the first example that we're going to be looking at together is on page 268, and it's example number 1. But before we get to that fun stuff, let's just talk about a ratio. Now, this is the definition that's in your book on page 268, and I would highly recommend that you put that in your math notebook because it's important, and we're going to be talking about it a whole bunch, all right? So math notebook, this stuff, important, okay? All right, so ratio is a relationship in which for every x unit, we're using x as just a variable right now, right? It's just kind of standing in for something, okay? X units of one quantity, there are y units of another quantity, okay? And again, y is also just a variable. It's just kind of a stand-in for whatever we're going to be talking about, okay? Now, there's a few different ways that you can write a ratio, okay? And remember, these are just kind of comparing two different things, a relationship, kind of, a little ratio comparison, if you will. Anyway, so 3 different ways you can write it, okay? So this is x to y, all right? So whatever this quantity is, 2, not like the number 2, but like TO, and then y, whatever that second quantity is, all right? You might also see it as x and then 2 dots, this colon right here, and then y, okay? Again, that's comparing whatever this x quantity is with whatever this y quantity is. You might also see it be written as a fraction, x over y, okay? So again, I would really highly make sure that you pause this video right quick and write this down, super important. Now, that we kind of understand what ratios are a little bit, let's start looking at it in action, all right? Example number 1, page 268. All right, so again, example number 1 on page 268. Here's the story. Tom's Pet Service takes care of cats and dogs. Good for Tom, love him. Currently, there are more dogs than cats. Compare the number of cats to the total number of pets at Tom's Pet Service. So notice, we are not comparing cats to dogs. We're comparing cats to the total number of pets, right? And here's a couple different ways we can write it, right? We could do cats to total pets, cats, that colon, 2 pets, right? And then cats over total pets, okay? So here are 3 different ways we can write our ratio, of course, once we get more information, right? Again, we're comparing the number of cats that they have to both cats and dogs, like the total number of cats that our little friend Tom over here has under his care right now, okay? Now, if you look at page 268, you'll notice that there's some more information. Let's add it. So once we get some more information, we learn that there's 14 cats and 17 dogs. Now, I know that the goal of this whole problem is to compare the number of cats to the total number of animals, but for a second, let's just kind of take a little side trip, if you will, and let's talk about cats to dogs, okay? So 14 cats, 17 dogs. If we're comparing cats to dogs, we could write it as 14, and that colon, 17. Okay, we could also say 14 to 17 or 14 over 17, right? We talked about all these different ways you can write ratios. This just happens to be Mr. Schlecht's favorite, so that's why we're going with this. You'll also notice that there's a picture, okay? So this blue rectangle right here represents the number of cats that we have. That's 14, all right? And then likewise, this red rectangle down here represents our dogs, and we have 17 of those. Notice, why do you think the red rectangle is longer than the blue rectangle? Because 14 is smaller than 17. 17 is bigger than 14. That's what we're representing here in this visual or in this picture, okay? Now, my friends, how in the world are we going to figure out how many total pets Tommy has? Okay, if he has 14 cats and 17 dogs, then what's like his total amount of animals? So we would add the cats and the dogs, right? So in order to get total pets, we would take the 14 cats, add that to the 17 dogs, and our answer would be 31, meaning that he has 31 pets that he's taking care of. All right, so now let's go back to the original problem, and it wants us to compare the number of cats to the total number of pets. Total number of pets, number of cats, all right? So now let's look at how we would compare those two quantities. So now we're comparing the number of cats to the total number of pets. And remember, that's 31, okay? So what I've done down here for our picture is I kept the cats just as is, but then I also added those cats to our total number of dogs, right? And then this bar down here, which I know is red and blue, that represents the total number of pets that we got going on here over at Tom's, okay? We've got those 17 dogs, that's represented by that red piece, and the 14 cats, just kind of think like I moved that blue bar down to over here, right, to show that relationship as well. So we can compare the cats to the total number of pets by doing 14, that colon, 31. We could also write 14 to 31 or 14 over 31, right? Again, these are the three different ways that we can represent a ratio, which again, just compares two different quantities together, shows that relationship between the number of cats and the total number of pets. Okay, my friends, so now let's look at example number 2 on page 269. Here's the story. The ratio of footballs to soccer balls at a sporting goods store is 5 to 3, all right? So every 5 footballs, that means that there's 3 soccer balls, okay? So if the store has 100 footballs in stock, how many soccer balls does it have? Now let's look over here. So here's how we can write all these different ratios, right? We can either do footballs to soccer balls. We can do footballs and then that colon, soccer balls, or footballs over soccer balls, right? So again, we're comparing these two quantities together. The information that we have is that we have 5 footballs, and that means that we have 3 soccer balls, right? And what we're trying to figure out is, hey, if we have 100 footballs, then what's that mean for our soccer balls, okay? You'll notice there's also some handy dandy little visual representations, some pictures on that page. So let's put that up here too. So Mrs. Schlecht has included these lovely drawings, right, that are also in your book on page 269. So up top, this is like our current spot where we're at, right, like the current reality. 5 soccer balls, and what you'll notice is I have 5 different boxes, and there's a number 1 inside each of those boxes, okay, because 1 plus 1 plus 1 plus 1 plus 1 equals 5, okay, so each of these boxes represents 1 football for a total of 5 footballs. Now, we're trying to match that same amount, right? So then each of these red boxes down here also just have a number 1, and that's representing the 3 soccer balls, right? 1 plus 1 plus 1 equals 3 soccer balls, okay? So again, currently where we're at. Now, here's the piece we're trying to figure out, okay? So we still have the 5 boxes up top for the footballs, still have the 3 boxes down here for the soccer balls. I kept that same ratio because that's really the only information that we actually have to go off of, okay? So just keeping that around. But now these 5 actually represent 100, okay? So think to yourself, well, if this plus this plus this plus this plus this equals 100, then what does each individual box need to represent? So in order to figure that out, we have 100, which is our total number of footballs, and then I'm dividing it by 5 because there's 5 different units or 5 different boxes that we have here, okay? And we know that when we take 100 and we divide it by 5, our answer or our quotient is 20, okay? So what that tells me is that each of these individual boxes are 20, okay? So 20 plus 20 is 40, plus 20 is 60, plus 20 is 80, plus 20 is 100, okay? Now, just like up here, how it was ones and then ones down here, right? Each box represented the same quantity. There was just more blue boxes for footballs than there were red boxes for soccer balls. That same idea down here. So if each of these blue boxes represent 20, that means that each of these red boxes also represents 20. So if each of our soccer ball boxes represents 20, right? So 20 plus 20 is 40, plus 20 is 60, 60 soccer balls, right? So that means that if at this sporting goods store, they have 100 footballs, that means that they also have 60 different soccer balls, okay? So here's like a picture to kind of help us figure out what's going on. Now let's just look at some numbers and see how we could have done this, like numerically, just like in math talk, okay? All right, my friends, so if we're using a ratio, and remember, we can write ratios different ways. This just happens to be my favorite. That's the one I'm going to default to, okay? Originally, we knew that we had 5 to 3, right? 5 footballs to 3 soccer balls. And the information it gave us was then that we had 100 footballs, all right? Now, what you could do is you could think to yourself, all right, how do I get from 5 to 100? Right? What operation, multiplication, do I use in order to do that? And we know that we would take 5, multiply it by 20, and that gives us 100. Now, because we want to keep everything fair and equal and balanced, right? Whatever you do to this side of your ratio, you also need to do over to this side of the ratio, right? Okay, you can't just like make up a new rule over here because then the whole relationship, the whole comparison of these two quantities out the window, okay? So if I did multiplying by 20 to get from this step to this step, I need to do the same thing over here, all right? So what's 3 times 20? Equals 60, okay? So this means that we could say that for every 5 footballs, we have 3 soccer balls. And when we have 100 footballs, we have 60 soccer balls, all right? Now, here's the super duper cool thing, at least what I think is super duper cool. This is like math speak. This is like our numbers, but it represents what's also going on in these pictures, right? So same information, just different ways to display it. Super cool. All right, my friends, the last problem I want to look at together is on page 270, and it's number 8. Here's our little situation. The ratio of blue cards to green cards is 2 to 5. There are 8 blue cards. Complete the diagram and explain how you can figure out the number of green cards, all right? So now let's look over here. So I just copied the diagram or the picture that's already in your book, okay? So we have blue cards, we have green cards. For these ratios, we can either write it as blue to green, blue, and then that colon green, or again, blue over green, okay? So the blue cards, when I have 2 of these units, that actually equals 8, all right? And then when I have 5 of these green units, that's the part I'm trying to figure out, like how many are those, okay? So let's start up here with our known information. If I have 2 boxes, which again have the same amount inside each box, that equals 8. So essentially, what's 8 divided by 2, or what plus what will give you 8? 4, right? So each of these boxes will represent 4 because 4 plus 4, that equals 8. Now, just like with our soccer ball and our football example, where each box had the same quantity inside the box, right? There just happens to be more green boxes than blue boxes. But if each of these blue boxes represents 4, that means that each of these green boxes also represents 4. So now, since we know that each of these individual boxes represents 4, I just input that information to our picture down below, right? So yes, there's 2 blue boxes, each one's 4, that equals 8. But how many green cards, right? It's asking us to figure out how many green cards we have. Well, once we were able to figure out how many blue cards we had or what individual setup we got for each of these boxes, I was able to translate that information down below, okay? So now, green cards, we have 4, 4, 4, 4, 4, all right? So let's think. 4 plus 4 is 8, plus 4 is 12, plus 4 is 16, plus 4 is 20. So that means I have 20 green cards, 8 blue cards. So now let's plug that information in to these different ratios we have down here. So we could write our ratios as 8 blue cards to 20 green cards, or 8 and then that colon to 20. Or again, we can write it as a fraction, 8 over 20. Now, if we were just going to our math and we weren't using these pictures, we could say that we would have 2 blue cards to every 5 green cards, right? And the information told us that, hey, we actually have 8 blue cards, right? So I plugged that information down here. And again, think to yourself, well, how do we get from 2 to 8? Well, we multiply by 4, okay? And then samesies, right? Got to keep it equal, got to keep it fair, right? So whatever you do over here, got to do over here, right? So 5 times 4, that gave us 20. All right, my friends, that was just a quick run through over these ratios. Super exciting. As always, if you have any other questions, please let me know.